In this recording, we'll discuss conservation momentum. We talked so far about several laws of nature, and actually, like Newton's laws of motion, Newton's gravitational law. Now, all of these, at some time, were thought of as laws of nature. We talked also of conservation of energy. Conservation of energy and conservation of momentum are the only fundamental laws of nature among the ones we have covered so far. Newton's laws of motion, for example, we have found out last century that they are not applicable all the time. Newton's law for gravity, also, we found out last century that it does not explain everything, and there is another law, the law of general relativity, that explains what we call as the gravitational effect more precisely than Newton's law. Now, conservation of momentum is still applicable, and it's a fundamental law of nature. What it says, the total momentum of a system of particles or objects will remain constant during the interaction of the components of the system, when no external forces to the system are present or when the external forces are balanced. Okay, this sounds tricky. Okay, but what it essentially says, if I have several objects, of course the several objects can be one object. If I have several objects interacting, like the billiard balls on a billiard hitting each other. Now, what this says is that total momentum will not change, irrelevant of what they do to each other. For example, in the case of the billiards, if we remember the video I showed before where we have the white ball hitting the others. Now, the overall momentum of the white ball and the other balls is going to remain unchanged, irrelevant of the fact that the white ball is going to hit the others or not, because that's going to be an interaction between parts of the system or the objects that you are going to treat as part of a system. And what this is saying is that momentum is going to remain unchanged until there is an unbalanced external force acting on the system. For example, in the case of the billiard, till a force is exerted, for example, by the rail, and the momentum is going to change. If we don't have an unbalanced external force, the overall momentum is going to remain the same. And mathematically, the total momentum, which we said before, that's the sum of all the momenta of each part of the system, is going to remain constant. Or the total momentum initial is the total momentum final. That's the law of conservation of momentum. Okay, hopefully examples later on will help clarify this. Okay, now again, so having this mathematically, for an isolated set of particles or objects, momentum is conserved, which means that the sum of the individual momenta is at any time is going to be equal to the sum of these individual momenta at any later time. That's what we mean. At any time, that would be my initial time, and at a later time would be my final time. Now, since momentum is a vector, this is not like the conservation of mechanical energy where we worry about initial and final condition only. Here we have to worry about them along directions, because momentum is a vector. So actually, we are going to have conservation momentum along the horizontal and conservation momentum along the vertical. We can have conservation momentum only along the horizontal if we have an external force acting along the vertical. Or we can have conservation of momentum only along the vertical. And that is if we have an external force acting, a non-balanced external force acting along the horizontal. Or both of them can be conserved along the horizontal and along the vertical when all of our external forces, if they exist, are balanced. But what's important, we have to worry about directions, an x and a y. Okay? Again, repeating this, in some cases, momentum can be conserved along one direction and not conserved along the other. It is conserved along the direction along which external forces are balanced. If the external forces are not balanced along a particular direction, it will not be conserved. Now, this is one key important point. Momentum is conserved even when energy is not. Okay, and we'll discuss that a little bit later on. Momentum is going to always be conserved, irrelevant of energy consideration.